Hello everybody, I'm Doug Watkins. Today we're going to be doing a demonstration on 6G pipe welding, combo welding, combo as in two processes. We're going to use GTAW, which is TIG. We're going to use SMAW, which is stick, and that's where you get the term combo because it's two processes. So to start with, we're going to prep our pipe, which is very important. And so the number one thing to start with is your PPE. Always wear two forms of eye protection and your gloves. So we'll get started with that. Now we're ready to start with our pipe preparation, which is very important. And the first important thing is to wear your PPE, which you always have some gloves, two forms of eye protection. You can grind your pipe with a sandpaper grinding disc only, but I prefer to use a hard carborundum or composite disc to grind with and clean inside and outside. Okay, notice that I have these two vice grips here. It is very helpful to have a holding device if you have those to do that, because it keeps the pipe from sliding around. So now we're going to clean the inside with a carborundum stone. Okay, now notice that the ID, which is the inside diameter of the pipe, is shiny, which is known as bright metal. When you have oxidation in carbon steel, it is rust, and TIG does not penetrate rust. In other words, rust will turn your arc away, so you're going to get what's called bright metal, shiny. Okay, now the next thing, I want to shine up the bevel with this sandpaper disc because it puts a very fine finish on it. So what we have here is completed prep of our 5-inch pipe, and notice how shiny it is. When we started, this looked shiny and it was gray, but honestly it's not shiny. It has fire scale from the plasma cutting it. So now we ground all that off. We have what's called bright metal. And in TIG welding, you use a knife bevel. The reason why it's called a knife bevel because it is actually sharp on the edges. And the reason why it's sharp on the edges is because TIG is not a penetrating arc, and to consume that bevel and put a positive root on the inside, you need to have it sharp where you can consume that bevel. So that completes the prep, and you may think sometimes, well, it took too long to prep, being too picky about that. But the thing is, when you prep your pipe properly, it gives you a win-win situation to start, and it's to your advantage to get the very best in prep. So what we have, I use a 532 spacer for this process with this rod, with a 1/8 rod. So I put the 532 spacer here, and then I set my pipe on it where it goes, where it's lined up properly, where the ID, which is the inside diameter, is flush with each other and is straight up and down and lined up with no mismatch, which would be called side to side. So our prep is complete. Now we're going to get ready to set up our welding machine. All right, now we have machine set up. And when you have a DC welding machine, any DC machine, you can do TIG welding. So ordinarily, people that are used to stick welding, you put your electrode holder on the plus sign, but this is opposite in TIG welding. We use straight polarity. So what we're going to do is we have our grounding cable goes on the plus side. Okay, and then now we have our cable that's going to go to our power block, and I'll show you the power block in just a moment, and it goes on the minus side. So what we have is our electrode holder, which we do use, you can use in this process, hooked into the negative terminal, and we're going to hook it on our power block. And what our power block is a means to connect our electrical current to our TIG rig. I'll show you that in just a second. And it's an argon hose that goes to our TIG rig. Screw it in there. You can hand tighten it. It's a 7/16 nut. You can put a little bit of snug to it if you want to, but as long as it's hand tight, you're good. And this cable has a copper wound cable in it that goes to your TIG torch. And your TIG torch consists of a means of having your tungsten in here to make an arc. You turn this on and argon comes out, which is the shielding gas. TIG welding does not have flux-coated electrodes because the argon comes out and makes an inert atmosphere where there's no oxygen in it. And the way the argon gets to this, we have what's called a flow meter. Usually they can be on your argon bottle or they can be plumbed in as they are in this case. We have an argon flow meter. We turn the argon on and turn it on here. As we see, this ball comes up in this flow meter, which means that we have argon flow coming out of this torch. You can feel it, and we have about 30 CFH is what we have on there, and that's suitable for argon TIG welding. So now, also on our machine, you have process switches on here. This machine is able to GTAW, which is what we're doing, TIG welding, SMAW, stick welding, and you can wire weld. But we're going to put in the process of GTAW because that's what we're going to use. And then we're going to turn the machine on. And for this process that I'm using, for this thickness of pipe, and I'm using 1/8 wire, what I like is 105 amps. And you can use different amperages, but approximately 105 is what I like. You can use less than that, you can use more than that. But in a beginning stage, this is a good usable amperage because it's forgiving in your travel and time that you feed your wire and use your hands to do that. So now we're ready to I use 4 tacks and we're ready to tack our pipe, and then we'll put it in position to get ready to weld. Okay, now we have our machine set up complete. Our machine is on, our argon is on. We have our clean coupons. They're bright, metal, shiny. We have a 532 spacer in here, and we put our pipe on top of the other one and look inside there and make sure that it is even, no mismatch side to side. So now we are ready to tack. Okay, our prep is complete. Now we're ready to tack, and there's a wide range of hoods that you can use. I just use a fiber metal hood with a number 10 fixed shade lens in there. You can use whatever you prefer, but this is what I like. So now we talked about gas tungsten inert welding, which is GTAW, which is TIG welding. We have a number 17 torch, and it uses argon. We talked about how to turn the argon, hook it up earlier. Every time you weld, you turn this argon on right here, and you just turn it on one turn. You don't have to turn it on several turns to make it work. So, and we use our tungsten very sharp. When you use the tungsten sharp, your arc is directed where you put it. And if you have a dull tungsten, it goes out several different directions and it's not concentrated, and we want to concentrate our arc exactly where we want it. So it's very sharp, both ends. You put it in your gas lens, get your stick out right, turn your back cap and get it tight. So now we're ready to tack. And you've probably heard tack welding. If you don't know what it is a process, but it's not a complete weld. It's a short weld that fixes our pipe in the position that we need it. So now we're ready to tack. And on carbon steel, what we're using today is ER70S6 rods, welding TIG wire as we call it. is usually stamped, and it has a number in there, and that way you verify the material that you're using. ER70S6, E stands for electrode, R stands for rod, 70 is your tensile strength that you use, S is for silica, which is a coating on here that keeps the rod from rusting, and 6 is a composition of your minerals in this rod. So now we are ready to weld, so we'll turn our machine on and we'll put a tack. What we have here is we have a coupon that's ready to weld. We're ready to tack it. The tack holds the pipe in position to get it in place where we're going to weld it. So what I do, we use lift arc TIG, which means you make contact with the metal with the tungsten, and then you lift it back up like a 1/16 of an inch, and you wait and get a molten puddle of liquid metal, and then when you do, you introduce this wire, and this wire melts from this arc, and you transfer it to this top side, back to the bottom side, and you make molten metal in here, and you travel, and you put a molten metal puddle in there that fuses both sides together, and then you quit, the arc breaks, and your pipe is fused together, at least one little small part to start with. So we did get our first tack in here. The first tack secures your pipe in the position where you're going to hold it to weld. And we do have our 532 spacer rod in here, but what you want to do, you do not want to make your second tack with it in there because it'll be locked in place. So we're going to pull that spacer. And when you tack metal shrinks down smaller and it will squeeze onto your spacer bar, and sometimes you got to pull it out of there with pliers. But what we have is a gap that's uniform, except it's squeezed down on our tack side and it's bigger on the untacked side. So we will squeeze it together and tack this side. So we'll push down on it a little bit to spring it down, and we're ready to tack. So now that we have two good tacks in here to secure our pipe in place where it goes, every time I break arc with my wire, you see this end where it's melted over the end? That's actually trash. You don't want that trash when you initiate a new puddle. So I always clip it off because you got a clean start. You don't want to introduce trash into your new puddle that you're going to make. So now we're ready to turn this and I like 4 tacks because that way our gap stays uniform. So now we're ready to put our third tack in here, right here. So now that we have our tacks in 4 places on the pipe, we're going to feather these out, which means we're going to thin out the ends of them. That way when you weld into them and out of them, this thick metal is consumed by your new arc. And that way you can't tell the difference in the start and the stop. So I'm going to grind the ends of these. So now, as you can tell, these ends, the starts and stops of these welds are thinned out. It's like a ramp. It's like a starting ramp to consume the metal and melt right into it. So now we're ready to weld these quarters. I will tack it up in a 45-degree angle, which is the 6G position, and we'll be ready to put the root in there. So now that we have our pipe tacked up in the 45-degree angle, we're ready to put our root in there and finish it. I have 4 good tacks, so the pipe is secured with a good uniform gap. What I'll do is I'll weld a quarter, like this bottom quarter here, and then I'll switch over to this top quarter here. The reason why you do that is for the pipe to have the same thermal draw, so it does not dogleg and bend. It'll be uniform, and then we'll go back and finish this quarter and the top quarter, and it'll be uniform and it will not bend. So we're ready to do that now. So the root pass is complete, and after you do that, you want to wire wheel it, because when you melt metal, even though you have an inert atmosphere, when metal melts and the coating on the wire, you will have a thin film on there, and you want clean, bright metal to start your next pass. So what we're ready for now, we're ready for our hot pass, and I like to put the hot pass on there at about 140 amps. So we're ready for that now. So now we have our hot pass complete on this side, and as you notice, when we come up here with our metal is only toe to toe on the root, because what it is, it's reinforcement for the root. It's not meant to be a fill pass. In other words, you don't make metal go all the way here and here. That's not the case. That's not what you want to do. You want to concentrate it right behind that root to reinforce that. And once you do that, that's a complete hot pass. Okay, so now that we have our hot pass on here, what we want to do is what we usually do. We wire wheel, because cleanliness is the name of the game. You want any contaminants, which are airborne particles, when metal cools and the coating on that wire. So we'll wire wheel it, and it'll be clean, and we'll be ready for our field pass with 7018. And so now, earlier we were in GTAW for TIG welding. We changed our machine, swapped our leads over to reverse polarity, and we have our stinger on the plus side, and we will change our machine to the SMAW mode, and then we will dial our amperage. So we turn our machine on, and I'm going to put it on about 90 amps. Close enough. And so, some people ask, how many passes do you put on a pipe to fill it up? There's not an answer for that. You put enough till you get it full enough, flush, and then cap it. So we're going to put us a stick pass on there, a field pass. Okay, what I'm going to do now is I'm going to start the field pass with a 7018 rod. And often the question that people ask is, what pattern do you use, or how do you run your rod? Basically what I do is I start an arc, and I proceed to look at the puddle and see how the puddle spreads out, and it's called oscillation, which you move your rod just a tiny bit side to side, and it'll make that puddle spread out a little bit. And that's all I use, is a little bit of oscillation. So we're ready now. So what we have now, we have our first field pass with a 7018 on here, and it's a single pass right behind the hot pass. What we want to do after that is we're going to split it up. We're going to have a double pass. We'll have one right here and one on top. It'll be a 2-bead pass, and it'll get us close to flush enough to cap. So we're ready for that now. So now we have our second field pass on here, and it's to one side of the bevel, but notice one thing. These are called the shoulders right here on the edge of the bevel and the edge of the bevel here, and we do not melt these off. This is very close to the edge, but you save that. That's a viewing point that it's like the side of the road to keep it between the lines. Don't melt the shoulders off, and you maintain a straight cap. So now we're ready for this pass right here. And as we talked earlier, between each pass, we'll wire wheel it to get any slag, anything off of there that we want clean metal. So we're full, we're flush, we're about a 1/16 below flush. So I'm going to wire wheel this now, and we'll be ready for a 3-bead cap. So we're progressing right along toward the finished pipe. So now we're ready for our 3-bead cap. And as we talked earlier, there's one question that people ask a lot. Where do you run your rod? We have a visible shoulder here, and we have a visible shoulder here. And we'll strike up an arc, and we'll run our rod right here, and our flux on a rod never gets outside of this shoulder. If it gets out of the shoulder, your cap is going to be wide. You keep your rod up here, and your puddle flows over the shoulder, and as it flows over the shoulder, that's when you move along. So you just want to barely cover this shoulder, and that's all you want to do, and be above flush. So we got our first bead on here. We'll call it our bottom bead of our 3 beads. We have it on here. We lapped over the edge, over the shoulder. We don't have any undercut because it's filled all the way. So we'll start and run 1 continuous bead up here to the top, our second bead, and we'll be ready for our 3rd bead. So we have our bevel full. We have our first 2 cap beads on here, and both of these beads basically filled up the groove, but we have a little bit of shoulder showing on top. So we're going to run our 3rd bead on here, which won't require much. You could call it a toe bead. The definition of the toe on a weld is where the weld metal meets the base metal. So we'll put a thin pass right here, and then we'll finish this weld out. And we do not want any undercut. We don't have any undercut on the bottom. It's visible that it's pipe all the way. And the main tip that I would have, people talk about letting pipe cool or not or whatever, but basically if you have the right amperage on your machine and your proper rod angle, and you have positive metal puddle as you go up and it follows you, that weld metal will fill any areas that you will not have undercut because you have positive metal. So we're going to run this on up and we'll be finished with this side. And also, I'm only capping this side. I staggered these. Even if you're welding both sides, you staggered your starts and stops so they're not in one place as to build like up a hump. You'll stagger 1, 2, 3, and that's why they're not in one place. So here's the last bead. Did you look at it?
No, I didn't look at it. I know it's good.
I was hoping you wouldn't run me off. All right, Doug Watkins saying bye for today. Thank you all for watching. Enjoyed doing the demo.